Okay, today is October 20th and you're here for Econ 249. What you're looking at on your screen is a flyer that I received from Alpha. It's about Amazon having an info session about job that they're hiring. It's tomorrow on Wednesday, October 21st from 12:15 to 1:30 during free hour. So it's a Zoom link and that's the meeting ID and passcode. So as I receive flyers like this, I post them or I email them to you. It doesn't mean that I'm affiliated with anything that I post. I just think it's useful information, something that can help you. So it's very rare during these times to find companies or corporations hiring. So if you see something that you're interested in, I urge you to attend. So this is tomorrow and it's a free info session. Christopher, you have a question?
Yeah, I was just gonna let the class know that I went to the last one, and like usually especially in masses like this, like sometimes it's hard to hear back, but I went to the last one, and the recruiters and the whole team really they always contact you, and if you really want to do it, they really help you pursue the interview. They give you resources, so it's very useful.
That's great. And it shows here at the bottom of the flyer that there's internship and full-time available, so two options. And Karina, do you want to add to that? You can turn your microphone on.
Yeah, so I'm the one actually who organized the event, and a recruiter reached out to me, and specifically what they're looking for is for any major, but this would be in their kind of area manager type position. So if you're interested in just like learning about Amazon and like what kind of different jobs they have, they'll be answering questions. And if you want more information on the role that they're hiring for, you can just um, either ask me through an email that I will put in the chat, so I can send you more information.
Perfect. Thank you. Yeah, I think put an email address that you want emails sent to in the chat box. That would be helpful. So we're going to continue with our statistics chapter 7 today. A reminder that your team Excel assignment number 3 is also due today. And you can post it or upload it on Blackboard, preferably as a Word document. One upload per team member is fine. Make sure you put the names of all the people who participated in the assignment. Any questions about the Excel stuff let's do today? No? Okay. So moving on to chapter 7. So chapter 7 is all about normal distribution, and I explained to you that normal distribution is one of 3 continuous probability distributions. So continuous because the normal distribution deals with values that are continuous data. Values of x are continuous. And because it's continuous, it can be a bit complicated. So we do not use a probability function or formula to calculate the probability. Instead, we use a set of standardized normal distribution tables. And that's what we did in the last class. We did an exercise on reading the tables. So this is actually what we covered in the last class. We did all these exercises as to how to read the table. Now, I didn't show you how to transform your x value into your z value. So today, that's what we're going to do. We're going to do a full word problem, and we'll do it slowly. Try to understand how to transform x into z, and then use the normal distribution table or Excel. I'm also going to show you how to use Excel. Okay, so starting with this slide, and so reading from the top, a set of final examination grades in an introductory statistics course was found to be normally distributed with a mean of 73 and a standard deviation of 9. Okay, so let's first understand that. First, you're told that you're looking at grades, scores in a course, and you're told that it was a normal distribution. So that's important information because you cannot continue if you don't know if you're dealing with a normal distribution. Because remember, it has to have all the properties of a normal distribution in order to use the standardized normal distribution tables. So this information is given to you. So if you're dealing with a normal distribution, then you have to know these two parameters. You need to know the mean and you need to know population standard deviation. And that's also given to you in the question. Okay, so they know that they've collected all this data. It follows a normal distribution. They know that all the data gives you an average of 73 and a standard deviation of 9. Now, before I read part A, question A, I'm going to ask you, what is the continuous random variable? What does the continuous random variable signify or denote? What does it stand for? Okay, let me write a few things first, I guess, and then ask that question again. So reading, yeah, Judah?
Continuous would be within a specific range. So in this case, the grades would be 0 to 100.
Okay.
Right? There's
Okay.
no predictor, I think, of what the grade would be. So that would be random.
Right. I agree. Oscar, you're saying the same thing. So I think you're both saying the same thing without actually saying what I'm waiting to hear, which is X. So you're both saying that X stands for continuous values, which in this case is scores or grades, anything from 0 to 100, could be 95.5, could be 67.75, so any value, anything as a decimal. So if I rewrite this question as a mathematical statement, I would say that X is distributed. Now that little squiggly line is read as is distributed normally with a mean, so that's my mean, of 73 and a population standard deviation of 9. So I just rewrote the question as a statement. X is distributed normally with a mean of 73 and a standard deviation of 9. So my question to you was, what does the continuous random variable signify? So the random variable is X, and what does it stand for? Well, X stands for grade. X is grade or X is score. So that's all I'm asking for. Not a particular number, but that's how you would answer it. X is a grade. Okay, so now part A. Part A is asking, what is the probability of getting at most a grade of 91 on this exam? What's the probability? What's the percentage? What's the area under the curve? What's the probability of getting a maximum of 91 on this exam? So the first thing I'm going to do again is to write my question as a mathematical statement. So I'm asked to find the probability when X is at most 91. In other words, I'm asked to find the probability when X is less than or equal to 91. So that's the same thing. Marking it here, at most is the same thing as less than or equal to. The maximum is 91. So 91 and everything less than 91. Okay, so I'm going to move on to the next slide, because that has more room for me to write. Moving on to that slide. Okay, so it's the same thing, but I'm going to write up here some of the information that we know. So we know that mean was given as 73, and the population standard deviation is equal to 9. Okay, so now again, I'm going to rewrite this question. What is the probability of getting at most? So we said most, another way of writing that is less than or equal to 91 on this exam. So what's the probability, meaning what's the percentage? Same thing. Okay, so now I can't just jump into reading the tables because I need to transform my x into z. So in the last class, I showed you that transformation formula to transform x into z was this formula. Z is equal to x minus mu over sigma. So I'll keep that here and make a note that that's your transformation formula. So now my next step is to transform x into z. So I continue writing. Now x, according to my transformation formula, is x minus mu over sigma, less than or equal to, now 91 minus, Brian, what's the value for mu? $73. And mean is, Colette, what do you have for mean? Sorry, not mean, population standard deviation. It is 9. Okay. So my next step is to rewrite this again. So I have the probability. Now this entire thing is actually z, right? That's my transformation formula. That's the whole point in this. So now I have z less than or equal to, and then Abu, do you have the value for 91 minus 73 divided by 9? Okay, so you guys say it's 2. I'm going to be a little bit more specific and say 2.00. Okay, 2.00. Now it looks more like something that we're used to seeing. So let's see if that's the right answer, Judah. Okay, so now we're saying that the probability when z is less than or equal to 2 is equal to something. So what's the probability when z is less than or equal to 2? So what's the first thing I should do? Remember in the last class when we were looking our exercises and we saw that we had to find the probability of z less than something. First thing we did was to draw our graph, bell curve, yes. So we draw the graph. This is just to visually see what it is we need to find. Now remember, this is the standardized normal distribution. So this center is 0. Now I'm interested in the value 2 because z is less than or equal to 2. So if this is 1, let's make this 2. I'm going to say this is equal to 2.00. And if it's less than or equal to, I shade to the left. If it's less than, I shade to the left. If it was greater than or equal to, then I shade to the right. Okay, so we shade to the left. My next step, now I'm going to look at the table because that's the method I showed you in the last class, right? So I look in the table for when z is equal to 2. So the tables are in Appendix B, like boy, page A41 and A42. I also uploaded it in my StatLab course tools document sharing. So I look at the second page of my normal distribution tables because the second page has the positive values of z. So if I here this as the positive values of z, I go down to when z is equal to 2.00, and that's the value that I see. It gives me the area from negative infinity up to z equals 2.00, and that value is 0.9772. Okay, so this is the method by looking at the tables. And we see that that area is 0.9772. Yazan, again repeating, I'm looking for z equals 2.00 on the table. So I'm looking on the second page of my normal distribution tables because that has all the positive values of z. I go down to when z is equal to 2.0, and then I find it at the yellow highlighted spot on the table here. So that means my area is from negative infinity up to 2, and that's 0.9772. So Christopher, I'll show you the way how to do it on Excel, but let me just finish up here. So that means we've got our answer. This is really it. Judah, you are right. You could have it as 72.72%, the same thing. Any questions about this method? Okay, so fairly simple, right? This is not complicated. The toughest thing might have been how to understand the question, the probability of getting most a grade of 91 on this test. So you had to have recognized that at most means less than or equal to. You have to have recognized that less than means you shade to the left on your graph, and you're asked to find percentage or probability, same thing. Now, I'm going to switch to Excel and show you how to do this on Excel. The formula is here at the bottom on the slide. That's the formula I will use. However, Excel is just going to give you the probability or the z-value. You could ask Excel to give you either one. But that means in order to get the probability or the z-value, you still had to have transformed x into z. So you still have to do this second step in order to get to the third step. And then you have to put in the value 2 into Excel because it's going to ask you here to put in that value for z in order to get the probability. So it's going to spit out the probability, but you need to know what to put in. So you don't need the table, but you need to know the transformation formula, which is here in red. And I strongly advise you to draw the graph before you get to Excel so that you can visually understand that you're still asking for the area to the left of the value because this is less than or equal to. Okay, so now I'm going to Excel and we're going to do the same problem there. So sharing my Excel screen. So here we're here on Excel, and I have two different formulas here to remind me how to do this. So part A said find the probability of x, and let me insert the symbol because I think I have it here. So less than or equal to, and we said when x is less than or equal to 91. So that's what the question asked us to find. And our next step was to find to transform x into z. And we said that would be z less than or equal to 0.00. Okay. So now I'm going to type in my formula so that Excel can give me the probability. The equal sign, and the formula is there highlighted in yellow. It's norm dot s dot dist open parentheses. Now it's asking me for the z value. Now since I already transformed x to z, I know my z value is 2.00, comma, true. So Excel knows that give me the probability when z is equal to 2. And then I hit enter. So immediately it's given me probability or the percentage. You can see here what our formula is in the formula box. So notice that the answer that we are getting is the probability from negative infinity up to 2. Okay, so Excel is also following that rule. It's giving you the probability from negative infinity up to 2. So it works for us because we wanted the probability when z is less than 2. So it worked for us. That's our answer, and you're done. So you didn't need to look at the tables, but you had to have transformed x into z. Questions, Priscilla? You said, so with Excel, we don't need the table, correct? Okay, so moving on to part 2, or part B of that question. So part B says, and actually, Christopher, part B answers your question. Percentage of students scored between 64 and 82. So here you're asked a range now. What percentage of students scored between 64 and 82? Percentage, probability, all means the same thing. Okay, so you're asked to find the probability. What's the probability? Or what percentage of students scored between these two grades? So I'm moving on to the next slide. So I have a blank screen to work on. So same question, what percentage of students scored between 64 and 82? I'm going to write down again the value for mean on the top was 73 and sigma, which was 9. Okay, so you have to find probability between 64 and 82. Okay, so question is asking, what's that probability? Now, if I decided to do less than or equal to 82, or if I kept it as less than 82, it's the same thing. It doesn't matter. The normal distribution, it does not matter. I know that with binomial distribution, what you just did for Excel assignment number 3, it does matter. But here it does. Okay. Again, I cannot read the tables or I cannot use Excel unless I transform my x into z. So here's a reminder of the transformation formula. Z equals x minus mu over sigma. Okay, so that's what we're going to do here. We have, can I have, Arzu, do you have the value for 64 minus 73 over 9? Arzu, you say -1. Okay, so I'm coming back to that. The center is x minus mu over sigma. And this is 82 minus 73 over 9. Next step is, so you say it is -1. And Dongyang, you say the center is Z, and this is 1. Okay, so again, a reminder that this center Z is because of the transformation formula, and going up to what Priscilla, your question is, it can be equal or greater than 64. So the reason why I deliberately did not put equals less than or equal to here is because it doesn't matter, right? If I left it or if I didn't put it here, it doesn't matter with the normal distribution. So disregard that. Christopher, your question is, so we only do the value for the higher integer in the set? We do it for both, right? We're doing it for the left and the right. I hope that answered your question. So make sure you understand how you transform x into z. Okay, so here we are. Now you might recognize something going on, and if you recognize it and you want to do it that way, fine. But there's 3 different ways of doing this, right? First is the table, then Excel, and then the third way I'll mention it later. Okay, so with the table, because the table is here, first thing I have to do, any method, is to draw my graph. So I'm going to do that, and then I want to visually understand that I'm interested in the area between -1 and 1. Okay, those are my 2 values, -1 and 1. So I shade the area in between the 2 values. And then I look up in the table. So this is method number 1, looking up on the table. When I look up on the table, I'm going to first look up the negative value of z. So my first sheet on the table gives me all the negative values of z. That last column, I go down the last column to z equals -1.00. When z equals -1.00, the area from -infinity, so all the way from the left, -infinity, up to that -1 value is 0.1587. The next value I'm going to look at is the positive value of z, so that's on the second page. On the second page, I look down the first column for the positive values of z, go down to when z is equal to 1.00, and then I should find it at 0.8413. And what should I do next? So if the area from -infinity to 1 is 0.8413, Arzu and Karina, you say to submit. Okay. 0.1587 is equal to Dongyan, you got 0.6826. Okay. Judah, do you see another way of doing this? Not Excel?
Sure. I mean, we already know the -1 to 1 range is 68%.
Okay. Yep.
Because of how distribution is normalized.
Do you remember what that's called?
Do I remember specifically what that's called? No. Oh, the empirical rule?
Yes, so that's what I was looking for. Yep, the empirical rule tells us, so if you recall, it said 68% all your data will fall within 1 standard deviation. So if you recognize that, here you have -1 and 1, immediately you think, okay, it's going to be 68%, and you're right, 68%. This is more precise, 68.26%, in fact, of all your data will fall within one standard deviation. So that was the method of figuring this out, a range when you're given these scores. It just so happened to be standard deviation of 1. Now I'm going to show you how to use Excel. So remember, again, with Excel, it's going to ask you for the z-value. So you need to plug in z, which means you should have done the second step and the third step in order to plug that in. So when I go to Excel, I'm going to ask for probability when z is -1 and z is 1. Okay, any questions before I switch to Excel and all this disappears? Okay, so sharing my Excel screen. So part B said find the probability between 64 and 82. And then we found that z is between -1.00 and 1. Okay, so I'm going to type in my normal distribution formula here, norm.s.dist, open parentheses, and now the z-value. So my first z-value is -1.00, comma, true. And it's telling me that the area from -infinity up to z of -1 is 0.158655. And then if I copy this down, the area from -infinity to 1 is this. So now I know, because I drew my curve, I need the area between the two. So I know I need to subtract 2. So I say take this value minus this value and enter, and that's my the color. Okay, any questions? So you could leave it as 0.62689 or 68%, same thing. Judah, just reading your note here, you said, yes, that's correct. Yep. Oscar, yeah, you recognize the empirical rule. Okay, so moving on to part C. So part C, we did a few exercises like this, but we didn't do it as a word problem. So here it says, what is the final exam grade? Only 10% of the students take a test scored higher. Okay, something different is going on here. You're given the percentage, and you're asked to find the grade. So what is the grade? What's the score? What's the X value? If you're given percentage, if you're given the probability, if you're given the area. Okay, so you have to do it backwards. So going to a new slide, same question here. I'm going to write my mathematical statement, because when I see this, I need to understand if it's correct. Okay, Judah, let's see if you're right. So I need to find X. I'll come back to this. I'm given the percentage. Okay, so I'm given 10%. So now let's understand the question. What is the grade when 10% scored higher? So this word higher is important. Higher than the grade is 10%. So 10% scored higher than some grade. So higher means greater than. And because I don't know what the grade is, I'm going to call it lowercase letter x. So now this is what the question is telling me. Probability when x is greater than some grade is 10%. So 10% of students scored higher than some grade. Okay, I'm saying the same thing in many different ways. Okay, again, a reminder for the transformation formula. is z equals x minus mu over sigma. So when you work on these problems in your homework, do it methodically, just the way I'm showing it to you, step by step. Otherwise, you tend to miss something. Okay. Next step, transform x into z, because there's no way you can use Excel or the table without transforming it. So we have x minus mu over sigma is greater than, now I don't know what this x is, so I just have to rewrite it the way it is. X minus, now mu in the question was 73, so that stays the same. And the question told me that sigma, population standard deviation, is 9. And that is equal to, now I'm going to take out the percentage and keep it as a decimal. So that's what we have. And I can do one more step. This, I can take the probability, and I know that now this has become z. That's my transformation into z. This x minus 73, I can't do anything about it, so I'm just going to rewrite it. I can't simplify it anymore. Okay. And this is still equal to 0.10. Okay. We're almost there, not quite. So to understand what the statement says, it says the probability when z is greater than some unknown number is equal to 10%. Now that unknown number, I'm going to rewrite it as lowercase letter z. Okay, so rewriting it to the next step, saying the probability when z is greater than, now I'm going to rewrite as lowercase letter z, is equal to 0.10. Now it looks like something that we did as an exercise in the last class. You give a probability, but you don't know the value for z. So we do the same thing. We draw our graph. And I still haven't used the table. I still haven't used Excel. Okay, so here's my graph. And it says greater than. So greater than means I always shade to the left. Sorry, I always shade to the right. Greater than means I always shade to the right. So if I shade to the right, I need to figure out if this lowercase letter z, that unknown number, is positive or negative. So I don't really know that. At this point, I'm going to make two graphs and try to figure it out. So this is graph number 1, and this is graph number 2. And this is when z is negative. So let's say here z is negative, here z is positive, because I don't know. And this is greater than, so I always shade to the right for greater than. Always shade to the right for greater than. I am told in the question that the area to the right of this lowercase letter z is 0.10. That was given in the question. So that means this area is 0.10. Now I need to figure out if I have positive or negative value of z. So what do you think? I should go with the left graph or the right graph? Dong Yan, why do you say positive?
Because only 10%.
Okay. Yep. So we know, looking at this graph, we know that at least half has to be 50%. So this does not make sense on the right to say that all this is only 10%. It doesn't make sense. So for that reason, this is not the one we're going with. We're going to go with positive z. Okay, so make sure you understand why we decided to go with positive Z. Okay, so now, wait, seems to be stuck for me. Okay, so we've decided that Z is positive. Now I'm going to look up in the table so I can find this positive value of Z. Okay, so I'm on the second page of my normal distribution table because now I know Z is positive, and I'm going to try to find the area. Okay, so the area means the area from negative infinity up to my Z value. So that area should be 1 minus 0.10. Any questions for me? So I'm looking for 0.90 in the middle of the table. Okay, 0.90 in the middle of the table. And if you can see, there's some kind of order here. When I look up in the table, 90, 0.90 occurs between these two highlighted values. So that means Z is equal to 1.2. And if I take the average of these, it's 1.285, or Z is equal to 1.8, or Z is equal to 1.29. You can do either one or any of those three that I just mentioned. You should have the right answer. I tend to go with the more conservative value, which is 1.28. I think your homework picks the average of the two. So your homework might pick 1.285. But your answer is not wrong if you picked 1.29. You should still get the right answer. Okay, so now I have looked in the middle of the table. So this is using the table method. I will also show you how to do it in Excel. So I looked on the table. I find it at 1.28. So that means Z is equal to 1.28. But that's not the final answer because that does not answer the question. The question is saying what is the final exam grade if only 10% of the students taking the test scored high. So I have to find the grade. 1.28 is not a grade. That's your Z score. So now I go back to this formula, x minus 73 divided by 9, which said that is equal to Z. Okay, so now if I substitute Z with 1.28, I can solve for x. This is divided by 9 is equal to 1.28. So now if you multiply both sides by 9 and add both sides with 73, Bipin, what do you get as the answer? So you're solving for x. What is x equal to? $84.52. Okay, so let me write that first and then explain. That's your final exam score, 84.52. Judah, how did you get that number?
How did I get 84.52?
No, the 93.44 initially?
Oh, I accidentally multiplied the 1.28 times the 73, and then I realized that is wrong, and I corrected
Okay.
myself.
Okay, got it. Okay, so this method is using the table. I'm going to show you how to plug it into Excel, same answer. So remember, you're doing it backwards, right? Now you know what probability is, you need to know what the z-value is. And once you get the z-value, you still have to come in here and plug it in to get your exam score, your x value. Okay, so going into Excel, now the formula is slightly different if you notice at the bottom here because it's the inverse. So I'm going to share my Excel screen. And now we're on part C. So part C is saying find the probability when x is greater than this lowercase letter x. And so that is found probability of z greater than, and I'm going to put lowercase letter z, unknown value. And that's what, oh, this we knew was 0.10, and this we knew is 0.10. Okay. Now, how do you find that? I'm going to use the blue shaded area here as the formula. So that's norm dot s dot inverse, and I just have to put the probability in. So that's it. I put in the probability 0.10. Now, as soon as I hit enter, I'm going to get the probability from negative infinity up to the z-value. But now, because I drew my curve, I know that the probability from negative infinity up to the z-value is not 0.10. In fact, it's 0.9. So I'm going to change it because I will want the answer for the positive z-value for area from the left. So then I hit enter, and that gives me the correct z-value when the area is 0.9. Any questions about that? Okay, so pretty simple, a lot simpler than using the table really, but you need to understand what it is you're finding. Okay, so transform x into z, draw your graph, and then come here. Then come to Excel and put it in. So these are the two formulae you need. One to get the probability and one to get the z-value. Okay, and then you would go back and apply it to your formula. Any questions for me? So that answered part 3 of this question. So you're saying that the final exam grade is 80.52 and only 10% of the students scored higher. The next thing I want to show you is this slide. Now, what you're looking at on the top left, that blue box on the top left, it has two columns. First column is the final exam scores. So it's exactly the same problem that we discussed, final exam scores, which means that x has the value from 0 through 100. And x can be anything, right? So x could be 66.55, it could be 84.52 like we just found. So these are all the values of x. And then the second column is blank. It's all the z-scores. Now, the reason I'm discussing z-scores here is in the example, the question deliberately said that you were dealing with a normal distribution. So very simple. You're told it's a normal distribution, so automatically you're going to use the standardized tables or Excel's formula, and you continue. But what if you're doing a brand new experiment, or you're trying a new study, and you're collecting a bunch of data. You're collecting different ages of people. You're trying to predict what's the probability of somebody being a certain age, for example. Or you're trying to find out how long it takes for people to graduate with a bachelor's degree. So you have, let's say, 50 different people in your sample. You ask each person how long it took. Well, some say it 4 years, some say it took 5 years and 3 months, some say it took 3 years and 6 months. So you collect all that data. So those are all your X values. Now, how do you know that's a normal distribution? You've never done this before. There's no work that's done before. You haven't anything to compare it to. So reading this box on the right in pink, how do you know if the data that you are dealing with comes from a normally distributed population? Because remember, you cannot continue with this. Although I said this is applicable across all disciplines, you cannot continue if this is not a normal distribution. So you need to check for normal distribution. So this is how we check. We have all our values of X, and if I look at my Z-score, these are all the Z-score values of the corresponding X values. So that's pretty simple, right? I can either use my transformation formula, do it manually, or I can put it into Excel and get Excel to do the work. Take every value of X minus mu divided by sigma. So I need to know what the mean and the sigma value is. Okay, so I plug in and I get all my Z-scores. Okay, now the graph that you're looking at the bottom right of your screen is called the normal probability plot. So on the horizontal axis, you have the Z-score. That's your second column that you calculated, all your Z values. The Y-axis has all the X scores. So if you plot that into a graph, we call that a normal probability plot. And if you get a graph that is a straight line like this, then you have a normal distribution. You have a normal distribution. It's not curved, it's a straight line. You can continue with your analysis and come with your conclusion. The average number of time is this to graduate with a bachelor's degree, or the probability of graduating with in 4 years is this. You can come up with your conclusion. However, looking at the graph on the left, if you plot your Z-scores on the horizontal axis and your X scores on the Y-axis, and you end up with a curve like this, this is telling you that it is not a normal distribution. In fact, your histogram will give you something that is skewed. So in this case, a long tail to the right. So it's not normally distributed, which means you cannot continue with your analysis. You need to do something a little bit more advanced. You need to use more complex statistical software, maybe remove outliers, readjust your data, collect it again to make sure that you're dealing with normal distribution. Okay. Any questions? So it's really cool that you can apply the normal distribution to anything, but you have to be careful that it follows certain rules. Although most applications are normally distributed. Okay, so I'm going to move on to the next slide. Let me see. And that's going back to our example about the GMAT test. So that example, let me just go back and show it to you first, so refresh your memory a bit. This is the original example. The GMAT has scores from 200 to 800. Scores are supposed to follow a distribution that is roughly unimodal and symmetric and is designed to have an overall mean of 500 and a standard deviation of 100. In any one year, the mean and standard deviation may differ from these target values by a small amount, but we can use these values as good overall approximations. So we did the first two parts of this question already, so I'm going to skip that. I'm moving on to the next slide, which is actually the third part of this question. So the third part says, another applicant says that her MBA program admits only people with GMAT scores among the top 10%. How high a GMAT score does it take to be eligible? Okay, so for me to understand this question, I need to write it as a mathematical statement. So I'm given probability. That's the first thing I see. I'm given my percentage. So I'm going to write here percentage that's given to me. I know that X has to do with GMAT scores. So how high a GMAT score, that's my clue that X has to be greater than some GMAT score. So they're asking me to find the score, which means they're asking me to find this lowercase letter X. Okay, so now I've written my question out. So I'm going to transform X into Z. So I have X minus mu over sigma is greater than X. Now mu, I'm told in this GMAT question, mu is 500 and sigma is 100. So going back to this, 500 over 100. Okay, next step is to rewrite this. This X minus mu value becomes Z greater than, now it's still an unknown, so I'm going to rewrite this as a lowercase letter z. And then this entire thing, I was given the area or given the percentage, so that's that. Next step is to draw my curve. Since we're dealing with greater than, I'm going to shade to the right. So greater than means I shade to the right, and I'm told this happens to be the same area as we worked on before, which is 0.10. So I know this is positive z. So now I would go into Excel and I would type norm inverse distribution formula when the area is 0.90, and Excel is going to spit out the value for z as 1.2. So my next step is to solve for x. X minus 500 divided by 100 is equal to this z value of 1.28. And then when I solve for x, multiply sides by 100, add both sides with 500, we get the value for x. And Dong Yang, what did you say? The answer is 628. So that means the GMAT score is 628. If you found the value for z and you saw the answer is 1.28 and you chose 1.28 as your answer, you would have been marked wrong. Because remember, there's one more step, right? So that one step is, or final step, is to find the value for x. So just because you get the same z value doesn't mean you're always going to get the same answer for x. It depends on what the application is, right? What the context is. Any questions for me? The last thing I wanted to just show you, Priscilla, your question is how did we get 628? So up to 1.28 is from the Excel work that you could have plugged in, same as we did before. And then you're going to look at this formula here to solve for x. So that's where we got this from. Okay, and moving on to this last thing. So I mentioned when I first began this chapter that there were two other distributions that were in the continuous distributions, and that's the uniform and exponential. So we're not going to spend time discussing the uniform distribution because, as you can see here, it's the same probability for different values of x, and it's really not practical, so we don't spend time on it. And with the second one, it's the exponential distribution. It's too complicated for this course, so we will not be looking at the exponential distribution. We only focus on the normal distribution. Christopher, you have a question?
Yeah, I'm sorry. I had a question on the last example, but my internet froze.
Oh no.
Um,
So the writings that I did on the screen have disappeared, but this is being
okay.
recorded, so you can go back and check and try to do a
Okay.
screenshot of it. Okay. Email me if you have a question. So this is really the last thing I wanted to mention. There are these two other continuous random continuous probability distributions. The other slides that you see are extra exercises for you to do on your own. They're extra practice. I won't be doing it in class today because I think it's quite straightforward. But I wanted to mention that the problems in your homework are excellent problems. Make sure you practice them and practice them for chapter 7 because it's very important that you understand how to find the z-values and how to apply them and how to get the probabilities. I want to mention about the second exam. So if you look on your syllabus, your second exam is next week, Thursday, October 29th. It's going to be taken the same time during your class time. Same format as before, very similar to your home questions. You will be sent a Zoom link where you have to keep your camera on and you take the exam on MyLab. This time I'm going to be a little bit more strict about having issues with the internet or cutting you off. I need very specific proof that that's happening because I won't be able to let you in or let you complete it, or if you didn't have enough time, etc. Okay, same amount of questions as before, same amount of time. What's going to be on the second exam is everything after the first exam. So that means chapter 5, chapter 6, chapter 7, which I just completed today, and a little bit of chapter 10. I'm not completing the entire chapter 10, but just a little bit of. So best way to study is to practice your homework questions. Okay, any questions for me? So I don't give out practice exams, but there is the study plan on MyLab. So if you're confident with the homework questions, let's say for chapter 5, then I suggest you do the study plan for chapter 5, which is generating extra questions, extra exercises based on the homework and based on how you did. Same thing for chapter 6 and 7. Dongyan, just to confirm, you said chapter 5, 6, 7? Yes, and a little bit of 10. So it's everything that you see in the syllabus here. Rad, you have a question?
Yes, October 27, Tuesday, are we going to have a class that day, or are we reviewing class?
Yeah, we're going to have class. Yep.
Okay.
Okay, so I'm not sure if I'm going to have a formal review session or break it out into working problems. I haven't decided yet. Yeah. Any more questions for me? Okay, so again, your second exam is on Thursday next week, not this next week. But make sure you do your homework, and chapter 7 homework is very important. Okay, so we're done a little early. I'm going to stop recording.